Hello, my name is Dheeraj. Now I am going to give a small demo on motion in a plane. Now I am going to give a small demo on motion in a plane. Friends, what is motion in a plane? Okay, friends, what is motion in a plane? See, okay, suppose there are three axes, Nana. Suppose this is this is x-axis, this is y-axis, and this is the z-axis. Okay, in this in three coordinate system, if x y z are three, if x y z are three mutually perpendicular axes, if x y z are three mutually perpendicular axis, then okay, if out of three coordinates, okay, out of three coordinates, two coordinates, okay, change their position. If two coordinates change their position with respect to time, that is called motion in a plane. Motion in a plane indirectly means it is two-dimensional motion. Indirectly it means two-dimensional motion. What are examples of two-dimensional motion? Now I am going to give examples of two-dimensional motion. First example is the circular motion. The next example is the projectile motion. First example is circular motion. The next example is the projectile motion. The next example is the projectile motion. The next example is projectile motion. Now let us try to understand. So circular motion is an example of two-dimensional motion because the object moves both in x coordinate and y coordinate. The object moves both in x coordinate as well as y coordinate. That is why it is example of projectile motion. Now I am going to explain what is projectile motion. I am going to explain what is projectile motion. See, what is projectile motion? I am going to explain what is projectile motion. Suppose, okay, this is, okay, any body which is thrown with an initial velocity u, making an angle theta to the horizontal is called projectile. Okay. So what is projectile motion? Any object which is thrown, any object which is thrown at an angle theta to the horizontal, at an angle theta to the horizontal, is called projectile motion. Okay. Here u is the initial velocity. U is the initial velocity. Okay, it is thrown at an angle theta to the projectile. The path followed by projectile is called trajectory. So this is the path followed by projectile. This OAB is the path followed by a projectile. This OAB is the path followed by a projectile. Okay, now we will see what are examples of projectile motion. We will see what are the examples of we will see, okay, what are the examples of projectile motion. Okay, the first examples of projectile motion are a bomb released from an airplane. Okay, a bomb released from an airplane is projectile motion. A bomb released from an airplane is a projectile motion. Next, a bullet fired from a gun. A bullet fired from a gun is an also example of projectile motion. Here, why it is projectile motion? Because if a bomb is released from an airplane, it will follow a, a parabolic path. So that is why it is the projectile motion. That is why it is the projectile motion. And next, we will see what are the assumptions of projectile motion. We will see what are the assumptions of projectile motion. In this, what are assumptions of projectile motion? There is no resistance due to air. There is no resistance due to air. There is no resistance due to air. Okay. The effect due to curvature of earth is negligible. The effect due to curvature of earth is negligible. What is the next assumption? So these are assumptions of projectile. There is no resistance due to air. Means whenever you throw any body, the first assumption is the force which opposes. Whenever you are in air, there is air resistance which opposes the motion. So if anyone falls from height, there is air resistance which always pulls you down, and the effect due to curvature of earth is negligible. Also, the effect due to rotation of earth is also negligible. The effect due to rotation of earth is also negligible. The effect due to curvature of earth is negligible. The effect due to rotation of earth is also negligible. Also, one more assumption is for all points in the trajectory, for all points, okay, in the trajectory. Trajectory means the path followed by projectile. Okay. The acceleration due to gravity, the acceleration due to gravity the acceleration due to gravity is constant both in magnitude and direction. Is constant both in magnitude and direction. The acceleration due to gravity is constant both in magnitude and direction. Next, I will tell what is the trajectory. I'm going to explain what is the trajectory. See, suppose this is projectile, Nana. This is O, A, B. The path followed by projectile is called trajectory. So what is trajectory? The path followed. The path followed by a projectile is called trajectory. The path followed by projectile is called trajectory. Okay. Next, I'm going to explain what are principles of projectile motion. I'm going to explain what are the principles of projectile motion. In principles of projectile motion, okay, the projectile motion, okay, in projectile motion, okay, the horizontal motion, projectile motion is in projectile motion, the horizontal motion and vertical motion. The horizontal motion and vertical motion are independent of each other. The horizontal motion and vertical motion are independent of each other. This is called physical independence of motion. That means there is no relationship between, okay, the horizontal motion and vertical motion are independent of each other. This is called physical independence of motion. Physical independence of motion. There is no relationship between horizontal motion and vertical motion. The two motions are independent of each other. This is the first principle of projectile. Okay. Next, one more assumption is the velocity of the particle. The velocity of the particle. Okay. The velocity of the particle can be divided into two parts. The velocity of the particle can be divided into two parts. One is horizontal component. Next is vertical component. Next is vertical component. Now we'll explain what is horizontal component and what is vertical component. Suppose this is projectile which is thrown with an initial velocity u, making an angle theta with the horizontal. Ox is horizontal, Oy is vertical. The horizontal component ux is horizontal component, uy is a vertical component. So what is ux? Horizontal component of initial velocity in x direction. Horizontal component of velocity in x direction. So what will be uy? Vertical component of velocity. Okay, what is uy? Vertical component of velocity in y direction. Okay, so from this you understand horizontal, the velocity can be resolved into horizontal component and vertical component. Okay, and what is the next principle? The horizontal component. Okay, the horizontal component remains constant throughout the motion. The horizontal component remains constant throughout the motion. The horizontal component remains constant throughout the motion. Okay. The force of gravity continuously affects the vertical component. The force of gravity. The force of gravity continuously affects the vertical component. The force of gravity continuously affects the vertical component. Okay. Next one. Here you can understand, okay. Suppose, okay, the horizontal motion is a uniform motion in projectile, okay. The horizontal motion is a uniform motion, whereas the vertical motion is a non-uniform motion. Why? Because when the body is projected vertically upwards, the speed decreases. That is why it is the horizontal motion is the vertical motion, whereas the vertical motion is a uniformly accelerated retarded motion. Very, very important for objective, Nana. Uniformly accelerated retarded motion. The horizontal motion is uniform motion, whereas vertical motion is uniformly accelerated retarded motion. I am going to explain the next topic, that is what are the types of projectile? What are the types of projectile? Okay. In this, the first projectile is called Okay. The first projectile is called oblique projectile. Oblique projectile. In oblique projectile, okay, it follows a parabolic path. Okay, this is the path followed by projectile. Okay. So what is the first projectile? Oblique projectile. Oblique projectile means any body which is thrown at an angle theta to the horizontal is called oblique, means angle. The next projectile is the horizontal projectile. Students, listen, horizontal projectile means the body is projected from some height. Okay, in horizontal projectile, suppose I will tell you the example. If a body is thrown horizontally from certain height, okay, it follows this path. So horizontal projectile means it always thrown from some height. Suppose this is aeroplane, Nana. Okay, if a bomb is thrown from aeroplane in horizontal projectile, okay, this is the horizontal projectile. In horizontal projectile, the object is thrown from some height. Is thrown from some height. Okay, this is the horizontal projectile. The next type of projectile is the projectile motion on an inclined plane. The next is the projectile motion on an inclined plane. In inclined plane, suppose I have an inclined plane. Okay, suppose this is an inclined plane, Nana. Suppose this is an inclined plane. A, B, C is an inclined plane which is angle theta. Okay. Suppose if any person throws any object, okay, on an inclined plane, okay, this follows the path. This is called projectile motion on an inclined plane. This is x-axis and this is the y-axis. Okay. So this is a brief introduction about what is projectile, what are examples of projectile. I hope you liked my video. Please subscribe to my YouTube channel, Dheeraj Koty. Physics faculty, signing off.